Hello everybody, welcome to computerhandle.com. So, we have done a lot of stuff regarding flowcharts in this chapter. And now before we head on to the practice questions and conclude the chapter, I wanted to include a revision lecture. And here is that lecture. So let's start. So, we started off with the concept of logical thinking. And how can we temporarily register the movements made by this minifigure onto the paper depending on the location and targets. For example, if you want to go from A2 to D2, you would proceed as up, up, up. Alright, and also we did an example of obstacle here, the same path right here. Alright, and this logical thinking are the basic foundations of computer science you need to remember. Alright, then in the next lecture, we revised the same concept, but this time instead of using the temporary hour notation, we have used flowcharts, and I had explained you the purpose of multiple shapes as well. Alright, and then of course we performed two examples regarding the minifigure. Alright, and the first example was regarding right. Alright, and the second example was regarding the position of the obstacle. Our objective was to catch the obstacle, right? So, is obstacle in row A? Yes, we had moved 2 points right. If obstacle was in row was not in row A, which means that the only possible scenario which we created was this position, then it means you have to proceed 2 points up. And that is exactly what we did, and then we had, no matter which was our pathway, we had ended the program like so. And this was just a rough basis, you can say a rough practice of what really flowcharts are. So this concept of flowcharts and two more things will now combine to create, will now then later be put together to form the basis of flowchart and logic design. So that was the first thing. The second thing was data types. And data is basically information. You can represent data in multiple forms. So we've got numbers, alphabets, Boolean, and of course date and time, which we are not going to use, which we haven't used in this chapter, and very likely we won't use it in the next chapter as well. Alright, so in numbers we've got two data types. We've got the integer and the real. So the integer can only store whole numbers, whereas the real can only store any number, but it cannot be negative. So integer can be negative, but it cannot be negative. It can be a whole number, it can be any number, even a decimal number. Then we've got alphabets, which can be represented as string with double quotations, a single character, short form char as single quotations. Alright, and of course we can also represent string as numbers, but bear in mind the number in double quotations is a string and is not eligible for mathematical calculations. And then we've got Boolean, yes or no, which we had seen and we will see in the flowchart. Then we proceeded along with the concept of assignment and input, process, output. Alright, we've got an input, the computer will process it, we've got an output, and we performed an example of +2. So whatever you input the number, it's going to add up to 2 to get the new output. Alright, the concept of assignment is storing a value, an integer, in a variable or any number. So this means that we are storing 6 into x. This means that we are storing 15 into x. And how assignment works is that we use this little arrow, and always to the left side of the arrow is the new value of the variable compared to the old side of the arrow, the right side of the arrow. Alright, so x is 15 here, so the old value of x is on the right hand side, will add up to 2 to get the new value of x on the left hand side, which will be 17. So when you ask x here, hey, what's your value, it's going to say 17. Then the old value of x here on the right hand side, 17, the latest value 17, will be subtracted by 3. You get the new value of x on the left hand side, which will be 14. Alright, then we also had a look at the mathematical operators, including the modular sign, which indeed returns a remainder instead of the divisor. So 7 divided by 2 has a remainder of 1, so it will give you a 1. But 6 divided by 2 has a remainder of 0, so it will give you 0. Alright, and here we also differentiated between the concept of integer and real, indicating that if we perform a calculation of dividing 7 by 2 it's going to return the answer 3.5 if x was declared as a real integer, but it would only return the answer as 3 if we had declared it as an integer, because remember, integers cannot hold decimal values. Alright, so if we perform a real calculation, then which will be converted into an integer, it will always output the highest possible whole number below the decimal point. Alright, so in this case it's 3. Then we had put all of these three things together to summarize what flowchart designing looks like. So we've got the shapes, we've got the data types, we had the assignment, mathematical operators, and the basic logarithmic functions, because at the end we aren't going to use the same squared word for an obstacle thing to program computers. We need proper hands-on flowchart. We need a blueprint, and this is what exactly that is. We've got an input, process, and an output. And here we had temporarily discussed the decision maker blocks and the comparison operators as well. Alright, and this was, by the way, the example of the driving license we had discussed, that under 18, if you're under 18, not eligible for the driving license. If you're over 18, which means if you're not under 18, you'll have the no hand side, eligible for driving license, and then the program will end. Then we had a more formal introduction to the selection box, or more like selection. Alright, and we had if-else statements which can only hold a 2-point junction, and we had case statements which can hold multiple junctions. Alright, and because we had an example for the if-else statement in the previous lecture, we discussed the example of the case statement in this lecture. Alright, and why using case statements in multiple scenarios is way better than using the if-else statements again and again and again. Of course, the case statements help you save some space in that scenario. Alright, and if none of these are true, it will head on to the otherwise part to perform your set processes or input-output, and then it's going to end the program. Then we have discussed the concept of loops, and what if we had connect an arrow back there, and how many times it had to be repeated. And we also discussed the concept of counting, which means that x is initialized to 0, the old value of x, 0, will be added up to 1 to get the new value of x, which will be 1. Is x 3? No. Now the old value of x is 1. It will add up to 1 to get the new value of x, which will be 2. Is x 3? No, it's still 2. We head on again. This time it will become 3. And then, yes, it will output program completed and end. And this is exactly how we use counting. One thing to remember though, we have to join the arrow before the counting process and after the initialization process. Alright, so if you put the arrow here instead, so it's gonna repeatedly say on reset itself to 0, and the program will infinitely run till of course the computer crashes. Then we have the types of loops here, discussed in a little bit more detail. We had the precondition loop and the postcondition loop. Alright, the precondition loop had the main condition first and then the main processes before the loop was completed. But here we had the main processes first, then we had the selection statement after on, which means that here the main process will repeat the main processes will repeat at least once. Well, here if the condition is already true, it won't even repeat once. And we even saw that at multiple scenarios, which included an example of precondition loop and an example of postcondition loop, and how we use both of the examples to also create a trace table for our sample data. And this is what we discussed in the previous lecture. After all, we had the count-based loops, which means that the loop will repeat by a set number with the concept of counting we used previously. Alright, and how the concept of counting will be used to set a number, to set a condition which will define the number of times the loop will repeat itself. And we even had an example of a scenario here with a trace table right here. Alright, and that is what wraps up our first chapter. Of course, right after the sample questions, which will be coming in a few lectures. So, an introduction to the sample questions. We've got 3 easy questions in the next 3 lectures, and then 2 slightly lengthy medium questions in the next 2 lectures. Alright, one thumb of rule which you should practice is that before you start on solving the you start on continuing viewing the lecture, you can pause the video, see the question for yourself, try to solve it yourself using all the knowledge we've taught you, and then compare your answer and solution to the solution we do here. This will really make you practice of trying to attempt it yourself will really make you more fluent in flowchart designing. Alright buddy, so that's it for this lecture. Thank you for viewing computerhandle.com. Take care.